In this virtual education session from the Clinical Excellence Commission, we're going to learn about the scatter plot. Before we begin, I would like to acknowledge and pay respect to the traditional owners of the land in which I'm hosting this virtual education session, the Gadigal people of the Eora Nation. I also acknowledge the traditional custodians of the various lands on which you all work today. We pay our respects to their elders, past, present, and emerging. The learning outcomes for this session, so at the end, the participant should be able to describe a scatter plot, interpret the data in a scatter plot, discuss the purpose of a scatter plot, and discuss when and how to use a scatter plot in their quality improvement project, create a scatter plot, and identify the difference between a scatter plot and other charts. For your information, the references used to inform this presentation are listed below, and you may want to either consider purchasing or borrowing some of these books if you'd like to learn more, particularly the three that I've highlighted in these images. So what is a scatter plot? Well, a scatter plot is used to study the possible relationships, such as an association or correlation, between two variables. If a cause and effect relationship exists between the variables, the scatter plot will show this relationship. The patterns on the chart will indicate if two variables are associated. And a scatter plot is also known as a scatter diagram or a scattergram. In this example of a scatter plot, we'll look at the possible relationship or correlation or association between the two variables. So what we're looking at here, is there a relationship between the number or the volume of patients in the emergency department on a given day and the time those patients need to wait to see a doctor in the emergency department on those days? So your hypothesis or your prediction or your hunch might be that increased volume of patients in the emergency department will increase the waiting time to see a doctor. And in this scatter plot, the data does demonstrate a relationship where the increase in the number of patients seen in the emergency department does increase the time they need to wait. Later on in this presentation, we'll describe to you how we determine the relationship in scatter plots when we look at the trend, strength, and shape of the data. The data for a scatter plot is collected and recorded in pairs. The data is either continuous data, also known as variable data, or attribute data, also known as discrete data. And there will be a detailed description of both continuous and attribute data explained later in this presentation. A minimum of 30 observations is recommended for a scatter plot. And in the example table below, for each patient, their data is displayed in the row. The patient's wait time in minutes is paired with that patient's level of satisfaction in the table. Each observation or point or dot in a scatter plot has two coordinates. The first corresponds to the first piece of data in the pair. That's the x coordinate. That is the amount that you go left or right in the scatter plot. The second coordinate corresponds to the second piece of data in the pair. That's the y coordinate, the amount that you go up or down in the scatter plot. The point representing that observation is placed at the intersection of the two coordinates. A scatter plot is composed of an x-axis, or that horizontal axis, containing the measured values of one variable, and the y-axis, or that vertical axis, representing the measures of the other variable. The independent variable is always plotted on the x-axis, the horizontal axis, and the dependent variable is always plotted on the y-axis, the vertical axis. So what is the definition of the independent and dependent variables? The independent variable, which is on the x-axis, is a variable that stands alone and isn't changed by the other variable that you're trying to measure. Whereas the dependent variable, which is on the y-axis, is something that depends on other factors. In other words, it can be influenced. So when the independent variable changes, the scatter plot will demonstrate the effect it has on the dependent variable. A scatter plot will demonstrate the relationship or the association or correlation between the independent variable and the dependent variable. For example, is there a relationship between the number of patients seen in the emergency department and the waiting time to see a doctor, or the time, in other words, minutes, a patient spent with a doctor and the level of satisfaction with the visit to that doctor. The caseload or the business of a hospital and the number of sick days taken by staff. And from a business perspective, increased spending on advertising and the volume of sales. And another example might be the traffic volume, in other words, the number of cars observed. And the dependent variable would be the carbon monoxide level in the atmosphere. I'd now like you to reflect on this table of data to the right. It's example data from a mental health call centre, in other words, a phone call centre. There are 4 continuous variables in this data set. The first variable is the total number of calls for the week. The second variable is the average time to answer the phone call in minutes for the week. The third variable is the average handle time of the phone call in minutes for the week. And the fourth variable is the percentage of abandoned phone calls by the client. So what pairs of data do you want to plot in a scatter plot to test their relationship? So what variable do you think might be influencing another variable? And what would the independent variable be and the dependent variable? So for example, is the total number of phone calls per week, in other words, that would be your independent variable, is it influencing the time taken to answer the call? That would be your dependent variable. The prediction would be that the higher the volume of calls in a week, the longer it might take to answer the phone call. Another comparison might be the total number of calls for the week being your independent variable and the average handle time being your dependent variable. Or another comparison might be the time to answer the phone call being your independent variable and the percentage of calls abandoned being your dependent variable. Sometimes you may not know what the independent or dependent variables are. You just want to compare 2 variables, then that is fine. So what I'd like you to do now is pause the video and you decide what you would like to test in this data set and what would you like to test in a scatter plot and what you think the independent variable and the dependent variables would be. So the purpose of a scatter plot is to display what happens to one variable when another variable is changed. Is there a relationship or a correlation or an association between the variables? If so, what influences what? As X increases, do you think Y will also increase? And this is demonstrated in this particular example to the right. Or, if X increases, will Y decrease as displayed in this scatter plot to the right? Or do you think there is no relationship between X and Y, which is demonstrated in this scatter plot? So a scatter plot helps to myth bust or support hunches, such as your hypothesis or your predictions. One very important thing you need to understand about scatter plots is that they do not prove causation. So just because your scatter plot shows that something is going on doesn't mean that a true cause and effect relationship exists. So causation can only be inferred from your scatter plot. There may be some other factors or other variables that are influencing the situation. So this scatter plot to the right, this example, indicates that the longer a patient was with the healthcare provider, the more satisfied the patient was. However, you can't be 100% sure that the increased time the patient spent with the provider has caused the patient to be more satisfied. With your scatter plot, you also need to look for outliers, and these are data points that are quite far away from the main cluster of data. This is very subjective when you call out an outlier, but basically what you need to do is go back to the original data source to see if there's not a data keying error or if there's actually something really happening in that data of interest. When you create your scatter plot, you need to make sure that you have clear labels so that people can understand and interpret the data. So you need to have a title which says what the variables are that are being compared, both the dependent and independent variables. You also need to clearly label the x-axis, in other words, that independent variable, and clearly label the y-axis, the dependent variable. Some optional things you can think about doing is stating what type of chart it is, in other words, it's a scatter plot. The definition, such as a thorough description of what is being measured. The data collection period, the start and finish time of, say, the audit or the survey. and the sample size, what n is, and preferably we'd like to see that to be over 30 observations. And also the shape of the scatter plot should be square, not rectangular. A scatter plot should be square in shape, not rectangular. With a scatter plot, you don't want to see too much white space in the chart area. So the example below has too much white space where all the data is gathered up the top right-hand corner. You need to adjust the minimum and maximum values of the y-axis and the x-axis so to fill the chart area. The way you do this is you right-click on the axis and then click on Format Axis and adjust the minimum and maximum bounds of the axis so that you get a graph looking more like this. To interpret a scatter plot, we look at three things. We look at the trend of the data, the strength of the data, and the shape of the data. So the trend can either be a positive trend, where the trend is increasing, or a negative trend, where the trend in the data is decreasing. The next step is to determine the strength of association in the data, and that can be described as either strong, moderate, weak, or no association. The strength of the association depends on how tightly the paired coordinates sit in relationship to each other. So we have three examples below. The first one is showing strong association where the data points are close together. The next example is of weak association in the data where there's more spread in the data points. And the third is an example of there being no association. And the third step when interpreting the data in a scatter plot is to look at the shape to determine if it's linear or non-linear. So a linear relationship between x and y exists when the pattern of x and y values resembles a line, either an uphill line with a positive slope or a downhill line with a negative slope. Non-linear is a change in shape in the data, such as parabola shaped. An example here is of non-linear data. It's now your turn to interpret the data in some scatter plots, and you can pause the video if you'd like to have more time. So look at this scatter plot and determine what's the strength, what's the trend in the data, and what's the shape. And the answer is this is a strong, positive, linear relationship. And now reflect on this scatter plot. What is the strength, trend, and shape? And the answer is it's a strong, negative linear relationship. And how would you interpret or describe the data in this scatter plot? And the answer is that it's a weak, negative linear relationship. And how would you interpret the data in this scatter plot? And the answer is there's actually no relationship in the data. And how would you interpret the data in this scatter plot? It's actually a moderate, non-linear relationship. Remember, we've got this parabola-shaped data. To create a chart, you'll need data. So, do you already have some data that's ready to go? Or is the data elsewhere and you'll need to extract it? Or the third option might be that you'll need to collect data from scratch. So to collect data from scratch, you may need to do either a clinical audit or a survey of staff or patients or family or carers using a questionnaire. And the design of your clinical audit or your survey is absolutely critical to the robustness of your data and therefore your quality improvement project. To collect data via a clinical audit, you may do this through various different ways. First of all, might be observing a process. Another way might be reviewing medical records or the electronic medical record information. Or you might investigate incident data. Or you may also assess compliance to a policy, protocol, or a guideline. And if you do a survey of staff, patients, or family or carers using a questionnaire, you must consider getting ethics approval, particularly if you're going to be sending this out to patients or families or carers. I'll now give a detailed explanation about both continuous data and attribute data. Continuous data is also known as variable data. It's obtained by recording a numerical value for each unit observed. It's depicted as either money or time, such as hours, minutes, or weeks, weight, length, temperature, or throughput, such as the number of patients seen in an outpatient clinic. It's a form of quantitative data and can be summarized by calculating the mean, median, standard deviation, etc. It can have a decimal point, in other words, a fraction, and it's used in run charts, statistical process control charts, such as the I chart and the X bar and S chart. It's also used in scatter plots and in a histogram. So some examples of continuous data in healthcare may include the wait time in minutes to be seen in a clinic or in the emergency department, the wait time in weeks for a community consultation or a clinic appointment or for elective surgery, the turnaround time of test results, such as for pathology or medical imaging, and the throughput or the number of procedures or tests performed or patients treated, say in the community or in a clinic or as inpatients, the number of surgeries performed, maybe the number of babies being born or the discharges from a ward, etc. Other examples of continuous data are like blood glucose readings or blood pressure. Some financial examples are like revenue, expenditure, or operating margins. And another example might be the duration of a consultation or a procedure, such as the length of time of a home visit or the length of time of a particular surgery. Attribute data, which is also known as discrete data, can be obtained by noting the presence or absence of a quality characteristic within a specified number of units. For example, it's the focus on counting either defects or non-conformities. Attribute data is used in a run chart, also a statistical process control chart, such as the C chart, U chart, or P chart, and it's also used in scatter plots. Attribute data can be broken down further into count data, and the data can be expressed as either the count or the number of defects or the rate of defects. It also can be broken down to classification data. That's data expressed as either a proportion or a percentage. So I'll now list some examples of attribute data. And remembering this is a focus on defects or non-conformities in healthcare. So count data would be looking at the number or the frequency or the count of incidents, in other words, defects or non-conformities. So for example, the number of falls or the frequency of needle stick injuries or the number of complaints or the count of pressure areas or the number of failed to attends. Rate-based data looks at the number of incidents or non-conformities per, say for example, occupied bed days, or the number of incidents per 1,000 occasions of service in outpatients, or the number of central line infections per 1,000 line days. In classification data, it's expressed as either a proportion or a percentage. This is where you have a numerator and denominator. Some examples are like the percentage of infections, or the percentage of clinic no-shows, or the percent of hand hygiene compliance, also the proportion of cancellations. I'll now show you how you can create your own chart using the ready-made templates on the CEC website. You can easily create your own chart using the user-friendly ready-made templates on the CEC website, and we have two different systems where you could do this. Either on the Quality Tool web pages, and you click on the chart that you want, and then there will be an Excel template for you, or you can use the Quality Improvement Data System or the QIDS system. You'll need to be registered to access the QIDS system by your local QIDS coordinator in your LHD or your network, and this is for New South Wales Health staff only. To get to the CEC Quality Improvement Tool webpage, you could use this URL or go to the website and the menu Quality Improvement Academy and Quality Improvement Tools. So this is an image of the Quality Improvement Tools webpage on the CEC website. And here are the different quality tools. And you click on the tool that you want, and there'll be information about that particular tool and the Excel templates. We have Excel templates for run charts, Pareto charts, histograms, and scatter plots. For New South Wales Health staff, there's a system that you could use to create charts. This is called the QIDS system or the Quality Improvement Data System, and you'll need to be registered to use this system via your LHD or network. You can find the login through Quality Improvement and then go to the QIDS and QAS section on the CEC website. When you're into the QIDS system, you need to click on Improvement Projects, and that will take you through to the chart templates. When you're in the Quality Improvement section in QIDS, you click on Charts and New Chart, and up will come a range of charts that you can choose from, such as a run chart, control chart, Pareto chart, histogram, or a customized chart. A scatter plot is created in the CEC QIDS system by initially keying the data into a run chart template and then converting this chart into a scatter plot. So using the Quality Improvement Tools webpage, we're now going to demonstrate how easy it is to create a chart using Excel from one of the templates that have been set up for you. I'll now do a demonstration on constructing a scatter plot in Excel from the template on the CEC website. When you open up the Excel template, you'll see tabs which will include instructions and the template for a scatter plot, scatter plot examples. The next tab is about interpretation of a scatter plot, and the last tab is regarding large data set instructions. So when you've collected your paired data for the two variables under review, the next step is to create the scatter plot in Excel. You can either use the template on the CEC webpage or the template in the QIDS system. So when you open up the Excel scatter plot template on the CEC webpage, scroll down past the definition and instructions and you'll find the table and the chart template. All you do is simply key your paired data into the table and the chart will automatically grow. And then follow the instructions to tidy up the chart. For example, give the chart a title and also label the x-axis and the y-axis. I'm now in the scatter plot template on the CEC website. So the information here is about facts you need to know about scatter plots. Then here we have some steps to follow to enter your data. And then here we have the table, the template table and the template scatter plot. I've started to put some data into this table. So I'll continue on and you'll see the chart grow as I put the information in. And you put the information in as paired data. I'm just making up this data. Then what you need to do is go into your chart by clicking it. Make sure that the chart is square in shape. Then you need to give it a title. State here what the title is. And also state here what the independent variable is. And also the dependent variable. And if you need to tidy up the chart because it's got too much white, you right click on the axis format and then you change the bounds, the minimum and maximum bounds. So that's how easy it is to create a scatter plot. We will now describe how you create a scatter plot in Excel from scratch. Scatter plots are very easy to create in Excel, even without the ready-made templates on the CEC website. You may want to create your own scatter plot without using the template, especially if you have large amounts of data. So the instructions in Excel to create a scatter plot are as follows. First of all, prepare your data in two columns. The independent variable is in the first column, the left-hand column, and the dependent variable is in the second column, the right column. Step 2 is to select the data by clicking and dragging the whole data set. Step 3 is to go to the Insert tab, then click Scatter, and then scatter with only markers. The chart will then automatically be created. Then you'll just need to format and tidy up the chart. And this would mean by removing grid lines, provide clear labels for the y-axis and the x-axis, and also give the chart a title. And now we're going to do an exercise, so it's over to you. So you're going to create a scatter plot. So look at the data in this table below and convert this information into a scatter plot. You can either draw it by hand or create your scatter plot in Excel or in the QIDS system, but that's for New South Wales Health staff only. And the answer will be revealed on the next slide. What's probably best to do is pause the video so that you can note down all the data for your scatter plot. So how did you go creating your scatter plot? Did you do it by hand or did you use Excel? Or for New South Wales Health staff, did you do your scatter plot in QIDS? And here's the answer. Did your scatter plot look like this? So this is showing a strong positive linear relationship. We will now explain the Pearson correlation coefficient. With scatter plots, there's actually a formal way of interpreting the strength of the relationship, and this statistic is called a Pearson's correlation coefficient. So the measure of the relationship or the correlation or the association between two variables in a scatter plot is called the Pearson's correlation coefficient, or Pearson's R. It's expressed as an R value which ranges from -1 to +1. The closer to +1 or -1, the stronger the relationship. So an example of the Pearson's correlation coefficient in action is that this scatter plot below has an R value of 0.93. And if you look at the table to the right, 0.9 to 0.1 indicates a very strong relationship. So interpreting this chart is that it's a very strong positive linear relationship between the time the patient has with the doctor and the patient's level of satisfaction. In other words, the data here infers that the longer the patient has with the doctor, the more satisfied the patient is. So when you look at this next scatter plot, it's looking at the time the patient has with a provider and the level of satisfaction from their outpatient appointment. It has an R value of 0.03, and if you look at that up in the table, 0.0 to 0.3 has no relationship. So this chart, the data is inferring there is no relationship with the time the patient has with the doctor or the provider and the outpatient satisfaction level. And the table is also relevant for negative relationships in a scatter plot. So the scatter plot below, we have a negative relationship between the time the patient had with the doctor and their level of satisfaction. So we have an R of -0.97. And in the table, you just use this row, which shows that there's a very strong negative linear relationship. You can very easily calculate the Pearson's R using Excel or some other statistical programs such as SAS, Minitab or SPSS. How it works is from the Home menu, select Function, and then you select Pearson and the array. The first array is your first column and your second array is the second column, and that will calculate your Pearson's R. So we're nearly at the end, and what we're going to do now is summarize the main features of a scatter plot. So a scatter plot, which uses coordinate points or dots, displays what happens to one variable when another variable is changed. The independent variable is plotted on the x-axis, the horizontal axis, and the dependent variable is plotted on the y-axis, the vertical axis. The data for a scatter plot can be collected via an audit or a survey. The data type is either continuous or variable data, or attribute data, which is also known as discrete data. The minimum data set we'd like to see is at least 30 observations of paired data in your scatter plot. The interpretation of a scatter plot is where you look at the trend, the shape, and the strength of the association. A scatter plot does not prove causation between two variables. It just shows the relationship or the correlation or association. A scatter plot should be square in shape, not rectangular. And the Pearson correlation coefficient, also known as Pearson's R, is the statistic used to determine the strength of the relationship between two variables in a scatter plot. It's now the scatter plot quiz time to test your knowledge. Please feel free to pause the video if you need more time. So true or false? In a scattergram, the independent variable is plotted on the x-axis, the horizontal axis, and the dependent variable is plotted on the y-axis, the vertical axis. True or false? And the answer is true. And please review this chart below. Is it a scatter plot? True or false? False. This chart is actually a run chart, and a run chart or a line graph demonstrates data over time. Is this a scatter plot? True or false? The answer is true. This is a scatter plot. So a scatter plot uses dots to display the data, and a scatter plot is used to study the possible relationship or association or correlation between two variables. Please review this chart below. Is it a scatter plot or a scattergram? True or false? False. It's actually a Pareto chart where the x-axis is categorical or nominal data rather than continuous data as you'd want to see in a scatter plot, and a y-axis is the frequency or the number or count, and it's using bars to display the data rather than dots. True or false? Is 30 the minimum number of paired observations or cases that is recommended for a scatter plot? True or false? And the answer is true. Describe the relationship in this scatter plot. Look at the strength. Was it strong, moderate, or weak? The trend, is it positive or negative? And the shape, is it linear or non-linear? So describe the relationship in this scatter plot. The answer is, it's a weak, negative, linear relationship. Review this scatter plot and describe the relationship. In your review, think about strength, trend, and shape. So describe the relationship in this scatter plot. And the answer is that it's a strong, positive, linear relationship. True or false? Scatter plots do not prove anything. They simply show the relationship between two variables and the direction and strength of the relationship. True or false? And this is true. Describe the relationship in this scatter plot. Is there any strength in the data? What is the trend? And is there any shape in the data? The answer is there's actually no relationship. Describe the relationship of the data in this scatter plot. Look at the strength, the trend, and the shape. So describe the relationship. The answer is that it's a weak, non-linear relationship. Should a scatter plot be square in shape or rectangular in shape? So should it be square shaped or rectangular shaped? The answer is it should be square. True or false? Chi-squared is the statistic used to determine the strength of a relationship between two variables in a scatter plot. True or false? The answer is this is false. It's the Pearson's correlation coefficient, also known as Pearson's R, and that's the statistic used to determine the strength of a relationship in a scatter plot. Chi-squared is actually used in a two-way table. Please consider following the CEC on any of our social media, such as Twitter, YouTube, or LinkedIn. This is the end of the session, so please let us know what you thought of this virtual education offering by completing the electronic evaluation survey or by sending us an email. Thank you very much and all the best.